Lesson is on inverse functions, and we are going to identify whether or not a function is one-to-one. So to be one-to-one, both the function and its inverse have to be functions. So the theoretical definition is a function is one-to-one if for a and b in the domain of f, if a does not equal to b, then f of a does not equal to f of b. Or equivalently, if f of a equals f of b, then a equals b. This is the one we see more often. So a little more simply, x and y cannot repeat for a one-to-one function. So we will check out the domain for number 1. It is 2, 4, 7, negative 2. So if you recall, a relation is a function if the x's do not repeat. There's only one x value. Okay, so that's good. The range is 1, 2, 3, 1. You can see that the y repeats. So this is not a one-to-one. I'll show you the mathematical symbols we use. 1-1, because y repeats. On the second one, this would be like a mapping. And you can see each name in the first circle, each superhero, corresponds to exactly one villain. So yes, this is one-to-one, because neither the domain repeats nor the range repeats. Okay, for a graph, a function is one-to-one if it passes the horizontal line test. Now, in general, you have to check the vertical line test. So we'll check the vertical line test. So to see if a graph is one-to-one, okay, number 1, it must pass the vertical line test. So each vertical line can only cross once. Number 2, it must pass the horizontal line test. So each horizontal line can only cross once. You can see that number 3 definitely passes vertical line test. So if we check the horizontal, each horizontal line crosses a dot once. So in other words, there's not 2 dots on one horizontal line. So yes, this is one-to-one. Number 4 passes the vertical line test, but if I draw a horizontal line, it crosses more than once. So this is not one-to-one. Number 5 passes the vertical line test and also the horizontal. So yes, one-to-one. So with the 2 types with numbers or sets with ordered pairs, x and y cannot repeat. If it's a graph, it must pass vertical and horizontal line test. Okay, next we're going to look at how to determine if 2 functions are inverses. Okay, so we use composition. So to determine whether the 2 functions are inverses, we have to show that f composed with g, f o g of x, is x, and g o f of x is equal to x. Now, if the first one doesn't work, we're done. So let's check out f o g of x. So that's equal to f of g of x. So we'll go ahead and write down what g is, 1/3 x minus 2. And notice we still are going to use the f function first. Okay, order is important here. So what is the equation for f of x? So it's 3 times something plus 6. Well, what goes in is not just a number, it's a function. So it's 1/3 x minus 2. If we distribute, we get x minus 6 plus 6, which is x. So we check that off. Now we have to show that GOF of x is equal to x. So this time, GOF of x is equal to G of f of x. So this is equal to g of the function 3x plus 6. So this is equal to your g function 1/3 x minus 2. Again, x is not just the variable x, right number, but 3x plus 6. If we distribute, we get x plus 2 minus 2 equals x. So because we've shown that both of these, when composition with each other in FOG and GOF, because they're both equal to x, this shows f of x and g of x are inverses. Okay. Now, you will not always be given an inverse, so we're going to have to learn how to find the inverse. So the procedures for finding an inverse, and we are assuming the function is 1-to-1. So we replace f of x by y, interchange x and y, solve for y, and replace y by f inverse of x. So again, look, notice what our directions say. A 1-to-1 function is given. Write an equation for the inverse. Okay, first of all, y is equal to 2 plus 1/2 x. Now we physically switch our x and y. So x is equal to 2 plus 1/2 y. We want to solve this for y. X minus 2 was 1/2 y. If you guys remember, to get rid of a fraction, we can multiply by the reciprocal. So I'm going to multiply each side by 2. Distribute on the left side, 2x minus 4, and then 2 times 1/2 is 1, leaving us with y. So we want f inverse of x is equal to 2x minus 4. Now, number 8 will be similar. Y is equal to 3x over x plus 1. Notice this is a rewrite. Okay, I haven't switched x and y yet. On the homework, I would just suggest that you write the problem with y. I wouldn't copy it with the f of x because we have to switch it to y anyway. So this is x plus 1. So x is equal to 3y over y plus 1. So we're going to we're going to multiply both sides by the denominator y plus 1. What we do to one side of an equation, we do to the other. Okay, so this cancels. So you get xy plus x equals 3y. Then we're going to move our y's to the same side. So coming over here, we have xy plus x equals 3y. Just to recopy that. So we're going to subtract xy from both sides. Now you really can't subtract it from the right side, so it becomes x is equal to 3y minus xy. We will factor out a y. And we're going to divide by 3 minus x. So x divided by 3 minus x is equal to y. And again, written in the correct notation, f inverse of x is equal to x divided by 3 minus x. And there is no shortcut here. Okay. Now, sometimes the problem has a restricted domain. And the reason is this. I want us to graph y equals x squared plus 3, the full graph. So if you notice it shifted up 3, 1, negative 1. So rough sketch, the parabola looks like this. It opens up, and notice that it fails the horizontal line test. This parabola is not 1-to-1. So this is not the parabola they intend for us to work with. So let's look at the parabola we have for this equation. Y equals x squared plus 3. There we go. Y equals x squared. Let me rewrite that again. Y equals x squared plus 3. But we're going to restrict the domain so that x is greater than or equal to 0. So that means I'm going to start at 0. If I start at 0, I get 0, 3, 1, 4. If I plug in 2, 2 times 2 is 4. 2 squared is 4. Plus 3 is 7. 1, 2, 3, 4, 5, 6, 7. So if you notice, it only graphs half of our graph, and therefore this is now a 1-to-1 function. Also notice that your range is y is greater than or equal to 0. So again, y is equal to x squared plus 3. Switch x and y. X is equal to y squared plus 3. Subtract 3. Square root both sides. You're going to put a plus or minus. Okay, so how do you decide what we're going to use for the inverse? Because both of those answers are not correct. Well, since here your domain is y is greater than, should be y is greater than or equal to 3. It's a positive answer, but this should be y is greater than or equal to 3. Then you're going to take the positive value, and that's based on the restricted domain and range here. So f inverse is equal to square root of x minus 3, where x is greater than or equal to 3. Now, if you're given a graph, the easiest way to find the inverse is to make a table of your original values. And then we're going to go ahead and we're going to find the inverse by switching x and y. Okay, so the furthest point here, I'm going to start here, is -4, -2. The next point is -3, +1, -1, +2, and 1, 4. So for the inverse, you literally switch your x and y, becoming -2, -4, 1, -3, 2, -1, and 4, 1. And if we graph this, -2, -4, this was 1, -3, 2, -1, 4, 1. Okay, I think I misgraphed one. Let me do this again. Okay. So -2, -4 is right here. 1, -3 is here. Okay, 2, -1 is here. And 4, 1 is here. And you can see that it mirrors across that line, y equals x. All right, so that's all for inverses. Hope you guys have a great day.